Hey guys, so today we're talking about plasma membrane and transport, and I wanted to give you the tip that will allow you to understand it all. So it's really easy when it's presented this way. Osmosis, tonicity, movement of molecule across membrane, all of that, it is all stemming from one understanding. And you've heard me talk about it before, but I'm going to insist again. It's all about the gradient. If you understand the gradient, you understand it all. And you always want to focus on where is the gradient coming from, going to, and what is the molecule in question that you're looking at. Because each molecule type, each element in a solution has a gradient, including water. And that's the trick for osmosis. So let's look at it. If you think of that board as where molecules are and hanging out and doing stuff, like the cup of tea, and I got some molecule here and some molecule there. When you look at the gradient, you notice that there are more molecules here than here or there, and there are more molecules here than here. So over time, what's going to happen is those molecules are going to spread, and over time, you will see the gradient disappearing. And I'm not doing that exactly right, but all the molecules are going to be spaced out, type of equality, kind of equality. It's like when you sip your, like when you make some tea, like you dunk your tea bag in the tea water, and what you're seeing is the tea is diffusing as you see, because there was a gradient of a lot of tea molecules in the bag, and that gradient without energy will not be maintained. There will be what we call entropy that will combat that gradient and force molecules to spread out, and that's the principle of entropy. We'll talk about it next week. So now that you understand the gradient, you need to make sure that the gradient is always attached to one molecule, always attached to one type of molecule. So once you get that, and you're thinking about uh, a phospholipid biomembrane right there, and of course that's just part of it, that makes a cell, and you have one molecule type first, and then you have another molecule type. This one has some outside, but one more inside, and that would be the in. Not that it matters so much for now, but that's the in and out of the cell. So when you look at it this way here, you just want to take one molecule at a time. So look at the green molecules here. They're only outside, not inside. So the gradient for green goes this way. And so molecules of the green matter will diffuse across the membrane that way, if possible. And what I mean by that is if that is small enough and non-polar, which means non-charged. If it's too big or polar, it's going to need some help across the membrane, right? If if there is a gradient like that, and you have in the membrane what we call transport molecules, transport proteins, which are simply funnels like that will help the molecules going through. If you think about the green molecule, they will go through that way because there is high potential energy here, low potential energy here, that's going down the gradient, the concentration gradient. Another way to look at it is to simply map the concentration of the green molecule, and you can tell by just making different size writing that there's a lot over there and a lot there, right? Actually zero here. So it would go from high to low concentration all the time, including water, really important. Now, if you want to maintain that concentration gradient, you need energy, right? So now you will need to make sure molecules don't move that way. If they're small enough, you will need some type of transport protein across the membrane that in that case will not just be a funnel, but will have some gated parts that require energy. And so in that case, using ATP, transferring that in ADP plus P plus, you end up having the possibility of bringing some of that green molecule against its concentration gradient. And that's really the key. If you're going down the concentration gradient, no energy is required. If you're going against the concentration gradient, from low to high, you need energy. So to maintain the gradient differential, you need energy. Otherwise, it will just go to, with entropy, it will stabilize and have either side of the membrane the same concentration. That will happen only if the molecules are small and non-polar. If they are polar or big or both, you're going to need some facilitated transport to see the natural transport of molecules from high to low concentration. You can also have active transport to go against or with the concentration gradient, because keep in mind, although the concentration gradient will push through the tunnels that are made by facilitated diffusion in this case here, that doesn't require energy, so that's facilitated diffusion, no energy. Let me write that. This one here is facilitated, this one here is active. Facilitated is a type of passive transport, whereas that's a type of active transport when you have energy involved. Passive transport doesn't require facilitated, it can just be if you're small and non-polar, you go through, it's passive, right? Osmosis is also passive, doesn't require energy. We'll talk about that in a second. So really, to re-emphasize, always going from high to low concentration. All molecules will do that. And if they're small and non-polar, or really small or non-polar, a little bit big but not too much, they can go through the phospholipid bilayer. We talked about the phospholipid bilayer and why you need to be small and non-polar to go through in the previous video, so revisit that if you need help on this. But if you're small and non-polar and you can go through, you will, by entropy, simply go from high to low concentration. If you need some help because you're polar or big or both, you can use facilitated transport that is part of the passive transport because it doesn't use energy, just has a hole. You think about just poking a hole through the dam that the membrane is, and literally the high concentration to low concentration, right? Now, if you want to maintain that gradient and keep pushing the green molecules out because the small non-polar they keep going through without facilitated diffusion, or you have facilitated diffusion channels that let the molecules go in, not really logical, doesn't matter, you will need to engage in active transport using energy to carry molecules against its concentration gradient, right? And that's really the gist of it between active and passive transport. So let's take a pause here, and I'm going to make a different video for osmosis. But the key, remember, gradients, and one molecule at a time. Here it's only about the green molecule. It doesn't matter about the blue molecule. Yeah. If you think of a blue molecule, there's a lot here in this case here, and there's not a lot in that place here. So I'll let you walk through what's going to happen to the blue molecule and what type of transport you need to go across the membrane based on, and you have to assume some stuff, so you can say, hey, my molecule is small and non-polar. What's going to happen? Well, small and non-polar, I know it's highly concentrated here, lowly concentrated here. So think about what's going to happen. And then you ask yourself, well, what if it's polar and or charged, right? Okay. And with that, I'll see you in the next one. Take care.